What the heck is a linear system? I'm gonna teach you how to solve it. But you wanna solve it by substitution. That means you're gonna substitute one of these equations into another equation for one of the variables. Usually when I'm doing substitution, I'm looking for something like that because that's an easy substitution. Let's take a look. Let's manipulate this to make it y equals, and then from there we can substitute that into this y. Let's take a look, and we'll move 4x over and we'll keep 5 there. So it'll be y equals negative 4x plus 5. Now that I know what y is, I can substitute it in here and then solve for x. And that'll give us our x value. So let's do it. 2x didn't change, minus 4. But instead of y, I know what y is. Y is here. Y is negative 4x plus 5. That's what we said. And we still have an equals 7 at the end there. Now we solve for x. Let's get rid of the parentheses first. 4 times negative 4x will be positive 16x. Negative 4 times positive 5 is negative 20. 2x did not change. 7 did not change. Now we add like terms. Here we go. We got two x's right there. Let's put them together, giving us 18x minus 20 equals 7. Let's add 20. Okay, add 20 both sides, get rid of the 20. X is going to be by itself very soon. Okay, 20 plus 7, easy, 27. And then you divide it. So x is on its own. And 27 divided by 18, if you don't know, now you know it is x equals 1.5. So I'm going to write it up here. X equals 1.5. Now we know what our x is. We can plug it into this equation and find out what our y is. Or we can even do it in here and it'll give us our y. Let's try it. Y equals negative 4, but instead of x, we're going to use 1.5 plus 5. And now we solve, and y is already on its own, so we just finished the question. Y equals, okay, negative 4 times it in, we get negative 6, and then we have an addition of 5 here. So y equals negative 6 plus 5 will be negative 1. That is how you use substitution to solve linear systems. Found both our x and y values. All right, solving linear systems with a real world problem. Mr. Ram invested $2,000, some at an annual interest rate of 8%, and some or the rest of it at an annual interest rate of 10%. Okay, after 1 year, total interest gained was $190. Now the question in your textbook or your test might state, how much did Mr. Ram invest at each interest rate? Because we have some variables here, some at 8%, the rest at 10%. What does that actually mean? We can do this by creating linear systems. So let's say x is the money that was put in at 8% plus y, which would be the rest of it at 10%. All of that would equal $2,000. Why is this the case? Well, because we know that I invested a total of $2,000. So whatever 8% was at and whatever the rest was at, those two together would be $2,000. Okay, now we can make another equation with the percentages. Because we said x is the money at 8%, we can do this. 0.08 times x plus 0.10 times y, right, the rest of it at 10%, that would equal our interest money, right, which is 190, because this is dealing with the interest. This is the total sum, this is the interest gain. With these two equations, this system will help us answer what actual money was put into which category. Solved by substitution, right? Let's substitute for y. So we'll move everything over, essentially just moving x over, minus x. And our new equation, I'll write it down here, will be y equals 2,000 minus x. Now let's substitute this y into the interest equation. Okay, so instead of 0.10y, it's 0.10, and then this new equation we found for y. So 2,000 minus x. We're gonna solve for x here. Essentially, how much did I put in at the annual interest rate of 8%? So let's do it, easy. Times 0.10 in here, 2,000 times 0.10, that gives us 200 minus 0.10x and 0.8x. They're like terms, so I put them underneath, and then it all equals 180. So what is negative 10 plus 8? Well, that'll be negative 0.02x. And there's a 200 there, it all equals 190. I'm gonna bring it up here, subtract 200, they'll cancel out. We'll get negative 0.02x equals negative 10, and then divide here by negative 0.02, negative 0.02. This will give us x equals 500. We're gonna back to our original here, sum at interest rate of 8%. Now we can say it was $500 at 8%. Now we can already guess, since it was 2,000. 2,000 minus 500, this is going to be $1,500, right? $1,500 at 10%. So you can say Mr. Ram invested $500 at the annual interest rate of 8%, and he invested $1,500 at the annual interest rate of 10%, which amassed him a total of $190 in the year. Okay, now we're solving linear systems, but man, these teachers, man, they keep giving us crazy stuff with fractional coefficients. What the heck? How am I going to solve this? This is too crazy. Don't worry, Mr. Ram's got you. Check it out. 2 and 3. It's a fraction. Let's get rid of the fraction. What's the GCF? Greatest common factor. Times it by 6, yeah? There you go. If you times both sides by 6, all of this by 6, and don't forget, you got to do this side too, 6. Watch what happens. 6 times 1 over 2, that'll give us 6 over 2, which is just 3. 3x. Look at that. We got rid of the fraction. 6 times 2, that's 12. 12 divided by 3, that's 4. 4y. And this one's easy, negative 6. So our first equation now becomes this. Cool. No fractions. I love it. Let's do the second one. 4 and 3. I'm thinking 12. Okay, times everything by 12. Y times 12, you get 12y. 1 over 4 times 12, you get 3x. And then 5 over 3 times 12, we get negative 20. So these are our new equations. Now we got rid of the fractional coefficients. Let's rewrite it so we get rid of the mess. We can now use substitution to solve the system. In equation 1, let's isolate x. Okay, so this is going to become, let's minus 4y, put y on this side, divide everything by 3x. So this would become negative 6 and negative 4y divided by 3 becomes x equals, this is now our x value. Let's substitute it in equation number 2, solve for y. Instead of 3x, this is our x. So let's do it. There we go. And minus 20. Now we solve for y. Let's get rid of the brackets first. Multiply in. 3 times negative 2, negative 6. 3 times negative 4 over 3, well, that just cancels out the denominator, leaving us with negative 4y. We still have a negative 20 over here, and we still have a 12y on this side. Let's combine the y's like terms. Okay, so let's put 4y on this side, giving us 16y. Over here, negative 6 and negative 20 become negative 26. Cool. Now we just have to divide by 16 to get rid of that y right there, giving us y equals negative 26 over 16. We can further simplify that into y equals negative 13 over 8. So we know what our y is. Now it's time for solve for x. Let's erase this junk. Using equation number 2, let's substitute y in. It is now 12 times negative 13 over 8. 3x minus 20. Okay, and we solve for x. So let's get rid of the brackets first. 12 times negative 13 over 8. That becomes negative 39 over 2. Over here, we still have 3x minus 20. Okay, let's add like terms, isolating x. So add 20 over here. This becomes 20 over 1 minus 39 over 2. Times this by 2, both in bottom and top. So we have a common denominator. We can add them. So 40 minus 39 all over 2. That becomes just 1 over 2. Okay, and this side, now we don't have this, so it's 3x. And then we divide x by 3 to get rid of that, both sides. We take the reciprocal. This becomes 1 over 6 equals x. Let's write it up here. There you go. We have our y value and our x value. So the key here, when you have fractional coefficients, just multiply the denominator by the LCM, lowest common multiple, to get rid of that fraction.